All right, it is now 12:30. So we'll go ahead and jump in. We only have 75 minutes together. And when I say only, it's because I love you all. Also, everything we're going to talk about is we're going to start off a little slow, but we'll end up going pretty in-depth. This is a 300-level session, so I want to make sure we have enough time to cover everything. First off, I am Jessica Dean, no relation to James Dean. My last name is spelled with 2 E's. I'm here because I love technology and community. It's pretty much the blunt of it. I have the best job in the world because I get to code, be a developer, talk to people about technology, and hang out with people. I get to take my passions and do it for a living. I focus heavily on Linux, open source software, DevOps, and containers. I love Disney and CrossFit/fitness, especially if you're in the general session. You heard me talk about CrossFit Ops. That's what I call DevOps. And you can find me on GitHub, Twitter, or Instagram at JLDean. It's the best way to get in contact with me. Short disclaimer, in the next 75 minutes, no matter how much I want to impart every single bit of information in my brain onto yours, it's not going to make you an expert. I'm not going to be able to do that. But this session is designed to get you thinking, to show you a little bit about what's possible in the world of containers, DevOps, Azure, Kubernetes, everything, and then also give you some sample code for you to go get started with on your own time. So we're going to dive right in. First off, our industry or our world of technology as we know it is changing and has been changing for the past few years. It's estimated that by 2020, 1 million devices per hour will be coming online. 1 million devices per hour. It's less than a year and a half away. By that same year, the average age of an S&P 500 corporation will be 12 years of age. Compare that to the 1960s, where the average age was 60 years old. Computers are getting younger, more and more devices are coming online. We're starting to see really significant growth. It's also estimated that 60% of computing would be done in the public cloud by 2025. And I actually believe that number is a little bit low because we're already seeing such a shift and such a momentum to the cloud, right? So how do we deal with this growth? How do we deal with our current state of our industry? Where do we start? What's the best approach? Which tech do I use? I don't want to get hacked. Can I reuse my code? How do I move to DevOps? There's all these questions. Our industry's changing. How do I adjust? What are the answers? To start off, we have to listen to our end users, right? We have to listen to our developers and our IT pros. Tell me if any of this sounds familiar. I need to create my applications and my code at a competitive rate without IT being the bottleneck. I don't need IT to limit what I can and can't do. When I give IT the application that ran smoothly on my system, all of a sudden they tell me it's broken. It's IT's fault. So as a result, my productivity and application innovation becomes suspended when I have to wait on IT. IT is the bottleneck. Don't worry, IT. I spent 10 years as a sysadmin. We get our moment. Here's ours. From the IT perspective, I need to worry about compliance and security. I have to maintain compliance with my corporate policy. I can't just give access to servers arbitrarily. I'm also unsure of how to integrate unfamiliar applications, the application that was written that works on your machine and not on mine. So I actually need to work with you. We have to work together. I can't focus on both server protection and application security and compliance. There's this need that we both need each other, right? That's the only way we can be effective. So if we work in IT, if we touch software, if you deliver software, if you write code, if you write the infrastructure and the architecture that software runs on, these are all of our IT stress points, right? We have to worry about security, we have to worry about efficiency, and we have to worry about supporting this rapid innovation we just defined. That's why cloud is so important. Cloud is the new way to think about the data center, right? Our traditional models was dedicated infrastructure for each application, each project. The hardware was purpose-built. The infrastructure and operations teams were distinct and separate. I often use an analogy where it's like a 6th grade dance floor. You have people on one side of the room, people on the other side of the room. No one wants to awkwardly come together and dance. The infrastructure and operations teams are distinct and separate. No one's even talking to each other, or the goals are not aligned. and customized processes and configurations. Everything's just tailored for that project, for that piece of hardware. But cloud sets us up for success. We now have loosely coupled apps and microservices. Our hardware is industry standard. Our teams that are delivering our services are service-focused DevOps teams. It becomes part of a culture. Our processes and configurations are standardized. We can repeat them. They're more reliable. That's why DevOps is so important, and it starts with people. DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. The most important word in that definition is value. If you are not delivering value, what are you doing? So you're pushing code changes and feature flags and updates. Do you have insight? Do you have telemetry? Do you have metrics? Do you know what your users are using? Do you know if they care about those features or what features they're demanding? How do you know if you're delivering value? DevOps companies achieve greater success when they implement these policies. You can deploy code faster. You're able to have a faster time to market. You have a lower change failure rate. You have a faster mean time to recover. Therefore, since time is money, you have increased revenue. There's so many benefits, aside from just not getting a phone call at 2 a.m. because the website went down. Key DevOps practices that you'll hear in today's session, and you've probably already heard: infrastructure as code. You might also hear pipeline as code, which is a newer term. Another newer term is DevOps or GitOps, right? Code that's in source control. Continuous integration, continuous deployment, automated testing, release management, performance monitoring. All of these practices help set us up for success. They tie into that value I mentioned and the insights and the telemetry and the data monitoring. How can I see if I'm delivering value? How can I test my site? How can I know that I'm going to be able to auto-scale based on CPU demand? All of these are standard practices. Can I roll back or roll forward quickly and simply? So why are we talking about DevOps and all these practices in a containers talk? First off, containers addresses the problem we just defined. For developers, it now enables this write once, run anywhere architecture. It enables and empowers microservice architecture. For operations, it's portable, right? It's now small, immutable, portable. I can put it anywhere. I can now rely on standardized development, QA, canarying, prod environments. It's going to be the exact same. I don't have to worry about the application working on QA, working on dev, working on canary, and then it hits prod and Java was out of sync and nothing works. It addresses those problems. But what is a container? And I promise you we're going to start off slow, but we're going to dive deep into it. I just have to make sure everyone in the audience is on the same page. First off, a container is not a real thing. It's process isolation. It's an application delivery mechanism with process isolation, and it's based on several key Linux kernel features. So you'll see here, up in the top left, a container is essentially operating system virtualization. Traditional virtual machines, you have your hardware, you have your operating system, then you have virtual machines on top of it, with their operating system, their applications. Windows Server containers differ a little bit more, because you could have containers sitting directly on top of the hardware, or you could also have additional isolation if you're using Hyper-V containers. However, like I said, I work with Linux, open source, and a bunch of third-party Mac stuff. I don't honestly know much about Hyper-V, so if you want to talk about Hyper-V containers, I will get you in touch with the team who can help you. Remember, a container is not a real thing. So some words that you'll hear in today's session when it comes down to Kubernetes, you'll hear things like namespaces. I feel like sometimes even if you know about Kubernetes and you've used it, people still don't define what a namespace is. It's what a process can see. It's things like your PIDs, your mounts, your network. And C groups is what a process can use. That's things like your memory and your CPU. And you'll see that as part of your deployments as you start diving deep into containers. It's important to understand what these words mean from a functional level. Let everyone take a picture of that. Now, what is Docker? How does Docker tie into Kubernetes and DevOps and all these things? Docker is, at the very foundational level, an open source container runtime. It has Mac, Windows, and Linux support. It's a command line tool though you can also install it in a GUI format. The Docker file format is the standard format for building container images. You can use it with Docker and Docker's products, or more commonly, you can use it with Kubernetes. The Docker engine is what also sits kind of under Kubernetes and what enables container orchestration, and we'll talk a little bit more about that. The Docker image format uses a layered file system. Layered file system looks like this. You start with a base image, and then you have all these different layers, and when I make a change to my image, just the layer that was affected gets rewritten. And then on the container layer, everything for the read and write happens above that. Here's another visual example. This is an actual layered example from one of my images for a game called Croc Hunter. If you follow me online, you've seen me promote the hell out of it. But for every single aspect of that Docker file, the label, the exposed port, command, environment variables, every single part is just a layer. So when I make a change, I only have to update that layer. It makes it fast, it makes it immutable, it makes it small, and therefore it makes it secure, better performance, better security. Virtualization against containerization. When you look at it from, again, a structural level, there's two types of virtualization, right? You have a hypervisor directly on top of hardware, or a hypervisor on top of a host operating system. But containers, even with Kubernetes, like I said, you have a Docker engine that sits on top of the host OS that enables your container orchestration. Advantages of using containers, as we talked about, right? Enabling that write once, run anywhere ability. But it also gives you fast iteration, agile delivery, immutability. Agile delivery is part of DevOps. Everything starts tying together. For IT, we already talked about how there's cost savings. I'm not having to spin up 8 different virtual machines, or 80, or 800. I now have more efficient deployment. I have now more predictable deployment. And then I also have elastic bursting abilities. That's if I'm using private, I could burst into public, or vice versa, based on need, based on CPU demand. I can burst where I need to go. Now I'm going to show you a little bit about containers, and we're going to start locally, and then we'll end up branching out and getting this all the way to the cloud. So I'm going to start over in Visual Studio Code, and I have a very simple, amazing Hello World, or Hello Microsoft Ignite 2018 application. Now, if I'm debugging this or trying to do something with a container, or I'm trying to get started with a container, I don't even have a Docker file. Now, if you saw some of the demos going around here, you may already know that I can, right from VS Code, add Docker files to my workspace. All I have to do is install the Docker extension. I go to my command palette, say Docker, add files to workspace. I choose my language, Node. My application serves on port 3000. I hit enter, and now the files in green have been added to my workspace. So not only do I have a regular Docker file that's all set up and ready for me to go, remember we talked about all those layers, I also have a more important Docker Compose debug YAML file. What this enables me to do is do live debugging on my system itself. So for example, I can go over to first I can do compose up. I'll choose my debug file, that's the Docker Compose I want to spin up and test locally. It's going to build my image locally, and it's going to set it up to where it's running. If I actually bring up that terminal, you can see it already built the container. It was able to do that really fast because I ran it earlier, so it cached all those layers. It doesn't have to rebuild anything. So now, if I go to my debug, and I drop this down, I have to add a configuration. I tell it I want to do Docker. It's going to automatically connect to my container, to the point where if I go and view the container that's running, we'll go to localhost 30,000, not 3030. We should see my awesome Microsoft Ignite application. I go back to VS Code. I can go over to my Node.js. This is a little bit harder when my screen is so big. We will set a breakpoint right here. I'll refresh the page, and I can hit the breakpoint live. I can do live debugging inside of a container. So that's great. I have my live debugging, I have my dev stuff, but now I want to get it out into DevOps containers. How do I automate this? I'm done with my application. Well, I already have the application sitting in a GitHub repo, out, obviously, in GitHub, and there'll be a link to that. We'll go ahead and zoom in and make this a little bit bigger. But now I want to create a pipeline building this image. I just built my image locally. I did everything, but I need to automate it. So I'll go ahead from Azure DevOps. I'm going to create a new build pipeline. We'll let it load up. I can choose 6 different options for Azure DevOps. I don't know if you know, you do not have to use Azure repos, though they are free, unlimited private repos. My code lives out in GitHub, as does every single one of my demos. So I'm going to go ahead and hit GitHub. I've already authenticated to my account. So I'm going to go ahead and type in the word ignite to find my repo. And I hit select. I'm going to choose the master branch. From there, I can choose what type of deployment or build pipeline I want to create. Well, we just built an image. So I'm going to go ahead and choose Docker container and hit apply. And from here, we'll make this a little bit bigger. Zoom out just a tad. From here, now I have to tell it where do I want to put this image? Where do I want to run it? If I want to ultimately deploy this out onto a container orchestrator that we're going to talk about, where do I push it? I'm going to go ahead and add in my subscription that has my container registry. I'll select my container registry. My Docker file's already been pushed. Everything's already in my repo. I'll choose the latest tag. I go over to push an image. I do the same thing, just selecting the image repositories, keeping everything aligned. Choose latest tag. And then I hit save and queue. That's going to go off and build my image and do everything I just did locally after I've already tested it. It's going to do it right here as part of a pipeline. So now we're going to switch over to the PowerPoint, and we're going to talk about container orchestration, dive deeper, talk about how you get your Kubernetes cluster set up, and we'll return back to this with the image it's going to build, and we're going to push it out into Kubernetes. But we're going to take a look at how it's still not perfect, and we'll have to dive deeper and deeper. So let's switch back over to the PowerPoint. We'll go back to here. We're going to now talk about container orchestration. We understand how Docker files work. We understand how to debug. We have everything local. But now we have to start working with the cloud. We have to start working with DevOps practices. So elements of orchestration are scheduling, affinity, anti-affinity, health monitoring, failover, scaling, networking, service discovery, and coordinated app upgrades. Using things like orchestration, I can roll forward, I can roll back, I can have that control we talked about earlier. Kubernetes is the de facto orchestrator. That's why everyone's talking about it. Docker's even gone all in. One of the demos you'll see today, I'm using Docker locally on my system, but I have it set up with Kubernetes. I don't even use Docker Swarm anymore. Kubernetes is the de facto because it's portable. It's public, it's private, it's hybrid, it's multi-cloud, it's fully extensible. There's a huge community. It's modular, it's pluggable, it's hookable. It's composable. It's a declarative language, so I can pretty much declare the state of the world as I want it to be, and Kubernetes will make it so. It's self-healing, has auto-placement, auto-restart, auto-scaling. Kubernetes empowers you to do more. I can now deploy my applications quickly, and we'll see that. I can scale my applications on the fly. I can roll out new features seamlessly. I can limit hardware usage to required resources only. What is Kubernetes, though? Like, it's great. It's de facto. What is it? It's an open source container orchestrator that automates deployment, scaling, and management of applications. It was originally written by Google, and it was donated to the Cloud Native Foundation. There are over 2,300 contributors to the Kubernetes project. It was based on the system called Borg that they use to run billions of containers per week. You have major names and major companies using this. Companies like Walmart, Concur, Pokemon Go for the game, Spotify, Twitter. Features include automatic bin packing, self-healing, scaling, service discovery, and load balancing. And you'll see that. I can easily have it set up my load balancer. Automated rollouts, roll backwards. We'll talk a little bit about secrets. Storage orchestration, batch execution. I can have jobs set up in it. How does it work? I have all these containers that I move over into my container orchestrator. They're spread across a series of nodes. In this case, I have 8 nodes. But now I need to add more containers. And I have limits and requirements and resource usage and all this stuff that's set in my Kubernetes definition files. I don't have enough CPU or memory for more containers. I can add more nodes, and now I can add more containers. So I can scale easily. Also, in the event of a failure, we talked about how it's reliable. Now I also have reliability because it's spread across so many, it's self-healing. It'll spin up the nodes that it needs when some fail. And my applications are still up and running. AKS, or Azure Kubernetes Service, is your Kubernetes cluster managed by Azure. We take care of the hard work, which is the control plane, and you only have to worry about your agent pool. It's easy to use. You can get up and running in 3 simple commands, though I like to say it's technically 2.5, and you'll see why. You can do automated upgrades and patching. You can easily scale your cluster up and down with 1 command. It's a self-healing control plane. We take care of it. We don't charge you for it. We're the ones that are responsible for it. And it uses open APIs. I get asked this a lot. Is it a Microsoft version of Kubernetes? No. It's 100% upstream, which means there's no forks. This is the same Kubernetes branch that we contribute to. To get started, like I said, it's 3 simple commands. The top command of AKS create will create your cluster. The second command is that half command that I told you. If you already have kubectl, which is the local command line tool, you don't need to install that again. You don't have to run that every time. It's on your system. And then the third command is what's going to set up your authentication, the get credentials. Who here remembers Docker Swarm and setting up an SSH tunnel and like remote ports and local and reverse and how much fun that was? Oh, no enthusiasm? Yeah, this is so much easier. I know, SSH keys, it's so crazy. And then the fourth command is just testing. Okay, now I can get nodes. I can see my cluster. Managing it is the same thing. I can list. And by the way, this is using Azure Command Line, which is open source and cross-platform. So it's our way of interacting with Azure. I prefer to do everything from command line. You can also do AKS upgrade. That'll upgrade your Kubernetes version very simply with 1 command. If you were trying to do that on an unmanaged version of Kubernetes, you're responsible for draining, decoordinating each node, upgrading the hardware, upgrading Kubernetes. It's not 1 command. You're spending days worth of work. So we simplify it. Same thing for if you want to scale. You start with 3 agents unless otherwise specified. You want to go to 10, you want to go to 100, you want to go to 1,000, 1 command. So without AKS, like I said, this is what it looks like. You have your control plane with your master VMs, either 1 or 3, and then you have your agent pool, and you have to be responsible for all of that, all the hardware, all the canonical upgrades, everything. But with AKS, or honestly with any managed version of Kubernetes, whether that's Google, whether that's Amazon, whether that's us, when it's a managed version, they take care of the control plane. And all you have to worry about is the agent pool. That's where your containers are running, right? So now we're going to go back and we're going to take a look. Our build should have finished. And I can see right here it has. So now I'm going to get it into Kubernetes. Now I've already done all those commands I just showed you. So I have a Kubernetes cluster up and running, and we're going to play with it. I'm going to hit release. And ideally, the web page is going to load. Come on, Internet. In the event that something fails, I have a backup computer. And right here, just like where we chose a Docker template, I'm now going to say, what do I want for my release? I want to deploy to Kubernetes. So I'm going to go ahead and hit apply. I'll name the stage. We'll start off with the basics, so I'll name it dev. We can see that because I'm building the release from my build, it already brought over an artifact. So it already brought over everything I built. But by the way, if you didn't know, with Azure DevOps, you can choose the type of artifacts you want. You don't just have to do what you produce from your build pipeline. You could transfer things from Jenkins. You can transfer things from GitHub or an Azure repository or Azure Container Service. I just leave it by the default of build. So now we're going to go in. I'm going to have to add a second task. So I'm going to search for Kubernetes. All the left-hand side is a task runner. All the commands I'm running locally, now I'm setting up as part of a pipeline. When I'm searching in this particular window, this is called the marketplace. This is also, not a lot of people know this, and truthfully, I just found out a few days ago. The marketplace, all the extensions are written in TypeScript, and they're all open source on GitHub. So if something doesn't work or something's missing, go write it. It's awesome. I mean, I can't even get over it. Anyway, I'm going to search for Kubernetes. I'll hit add. And now I have to set up my tasks. So if I'm brand new to Kubernetes, and Kubernetes, like I said, is a declarative language, we'll take a look at what an example Kubernetes deployment definition file looks like. It's written in YAML. But I don't want to write a YAML file. I'm still new. I'm still learning. I'm just trying to set up my pipeline and get familiar with this container orchestration. I can do kubectl run. That's the standard command you're going to run. So I'll search for kubectl run. The other thing I'm going to do is I'm going to switch to a different version of the Kubernetes extension. Version 1 is much better because I don't have to deal with context files or copying things or creating service principals. It does everything for me. So I'm going to deploy to this particular cluster. And I'm going to choose the resource group with my Kubernetes instance. And I'll choose my Kubernetes cluster. Now, I have to specify a namespace. And I don't technically have to. I can let it deploy into a default namespace. But if I'm going to teach you the right ways, I'm going to teach you the best practice ways. Every single deployment you should do should be in a namespace. It should be cordoned off. It should be secure. That way, especially when you're learning, if I blow anything up, it only affects that namespace. It also keeps things nice and secure from other applications. So, if I don't know my namespace, there's another really cool extension over in VS Code. It is the Kubernetes extension. And I actually have a list right on the left-hand side of all my Kubernetes clusters that my computer is authenticated with. I'll drop down, I'll hit refresh here, and I can drop down the menu of the namespaces. I can see all my information right from my VS Code. I can actually even add an existing cluster or create a cluster right from VS Code, which we're not going to go through today, but I wanted to show you. So we can see that I already have an Ignite 2018 namespace created. If I wanted to change namespaces, I could right-click on any of them and select a different namespace. But we're going to leave it at Ignite 2018, and I'll type that in here. Now we already put in run. The next thing I have to do is, not that one, is put in some arguments. Kubectl run what? I want to run a deployment. I'm going to give it a name, which let me go ahead and zoom in. Says kubectl run hello ignite. That's going to be my name, right? We're going to do that hello world application I just did. I'm going to specify an image, which is the image that I just uploaded to my Azure Container Registry, and the port. The port, we all know, of my node application is 3000. I don't have to do anything with secrets. I already configured that before the session. After the session, I will be writing a blog post explaining about how secrets work, because it's honestly too much to go into here. But I already set up the secrets, which gives my Kubernetes instance to this namespace to access my cluster, and my secret is only allowed to that namespace. The second command I have to run is expose. That first command is just going to create the deployment, just like what I ran locally on the system. So it's running locally, but how do I access it from the web? It doesn't do me much good. So I'm going to select my Kubernetes cluster again. Select the resource group, and I'll select the cluster within that group. We'll set the namespace. And then from here, I'm going to choose expose. That's going to create what's called a service. So that service is going to allow my cluster to be exposed and visible on the internet. So I'll go ahead and type this in. If we take a look at what that's saying, I'm now saying expose the deployment, hello ignite, with a load balancer that it's going to go out and create, port 80, target port 3000, right? 80 for web traffic, 3000 for the internal port. I'm going to zoom out. Again, I don't have to do anything with secrets. So I'll hit save, and then I'll hit release. So this is going to fire off the release, and it's going to do a full deployment right here from beginning to end into my Kubernetes cluster. And I'll leave this on in the background. And I will have to run a command to get my IP address, because I don't know it. There's no DNS. There's no insight into it. So this is great for getting started. But this isn't really effective from production or real-world use case, right? So first off, I'll leave this running in the background. I told you I'd show you what a YAML file looks like. So I should have my example right here. So this is an example of what a YAML file looks like, right? It's saying to deploy a pod. Here's an API vision. Here's a spec. Here's containers. Here's where I define my image right there on line 23. Image pull policy. Down at the bottom, there's even something that says image pull secrets. This is a lot of YAML, and this is a lot to manage. As I start doing more and more deployments, more and more services, load balancers, ingress controllers, persistent volume claims. By default, all the containers are stateless. Once my container dies, where does my data go? So I can attach volumes and storage. Now I'm starting to get very complex. Now I'm starting to get fun and real. But how do I manage it? That's what we're going to talk about in a second. First, we're going to go back and see if that deployment is done. We'll refresh the page here real quick. It looks like it is. So I'm going to go over to my command line, And I'm going to go ahead and do a kube-get. I have an alias, but I'll type in the full one. So we'll talk about kubectl get services. And I can see right here, here's my external service. So I'll copy that IP. I can also do kubectl get pods. And I can see that that pod is running. So I have my insight. Again, these are just the same commands I would run locally as I just did. So now I go over here. I'll repaste that in for that IP address. And I should see my same application load, which I do. So that was end-to-end. We built a Docker image. We debugged it. We pushed it up to ACR. I deployed it out through a pipeline. But we just talked about how complex YAML files are. So where do we go next? Let's talk about it. So there's release automation tools to simplify this entire experience even more. And they're built, again, still on DevOps practices. 2 of them I'm going to talk about are going to be Draft and Helm. But we have 4. We also have Brigade, which is event-driven scripting for Kubernetes. And, Brigade is event-driven scripting, and then Kashti is a visualization dashboard for Brigade. And by the way, all 4 of those are open source tools. Draft and Helm specifically, was started by a company called Deus, and we acquired them a little over a year ago. They work now on our team. They work closely with Kubernetes. And Helm is the package manager for Kubernetes. If you are a developer, you can think of it like NPM or NuGet, or if you're of the Debian persuasion, apt, or Alpine, APK. It's literally a package manager. It makes it easy for me to distribute my Kubernetes deployments. But it also bundles them up into tarballs, and when you break out that extraction, you actually have a series of charts. It contains your service.yaml, your deployment.yaml, your ingress.yaml, all those files I just talked about, it contains in a little box. And then, rather than having to go out and edit all those lines that I showed you in each file several times, you have one file called the values file. That becomes your knobs and dials, and I'll show you that. You can do easy updates. Because I just have one file, I want to make a change to my ingress, which has to also get attached to my pod, my service, and my ingress YAML. I make a change in one file, and it's templatized across. So I'll show you how that looks. You can also use Helm rollback. So the deployment that I just deployed with kubectl run and kubectl expose, if I rerun that pipeline, guess what's going to happen? It's going to break because the deployment already exists, and it has no insight into how can I upgrade it, how can I roll back, how can I delete it. If I do upgrade it and I apply a change, how can I go back to the previous version simply? Helm streamlines that. Here's a visualization of how that works. You have a chart, you have your database, your services. Essentially, Helm kind of becomes your infrastructure as code, your pipeline as code. Somebody asked me on Twitter, how do I really do infrastructure as code with DevOps? It's one of the key parts. All of my code, all of my deployments, every single demo I do sets up an ingress controller, attaches it to a load balancer, has Nginx attached to it, deploys out a fully standing DNS-backed website. But I do it in less than 5 minutes because I have everything streamlined as part of a Helm chart. So now I'm going to show you Draft and Helm, because I didn't explain what Draft is, but in essence, Draft simplifies Helm. It makes me the ability of creating a Helm chart take only 2 simple commands. So I'm going to go back over to my terminal window here. And the first thing I'm going to do is zoom in so you guys can see a little bit on the left-hand side. And I'm going to do all of this locally. We're going to cut the cloud out of it, and we're just going to show you how to streamline your Kubernetes deployment so you can play with it. I'm going to do bad Wi-Fi, because that's when I have to cut my Wi-Fi when the conference Wi-Fi sucks. And essentially what I'm doing is I'm just switching over to the Docker on desktop with Kubernetes. That was the one I told you I'm running, right? Now, I'm going to do one more thing. I'm going to go back into my demos folder, and I have a folder called Draft. This is a folder that I literally cloned from the Azure Draft repo. So this is something that you can go and get started with. But I'm going to cd into my Draft folder, and there's an examples directory. I'm going to clear the screen so we have a little bit more room to work with. I'm going to do an ls. There's a ton of languages that Draft supports by default. And Draft is able to do that with Helm to create your Docker files, your charts, everything for you using language packs. It can smart detect if you're using .NET or Go or PHP or Node.js or Python, all these languages. So I'm going to cd into my example Python directory. I'm going to go ahead and open that up in code. We'll zoom out here real quick. And you'll take a look and see what I have. Again, it's going to be a very simple hello ignite, simple Python application. I have one requirement, that's Flask. But I only have 2 files in this directory, and I want to do everything I just spent the last, 40 minutes doing with 2 commands. So I'll go back over to my terminal. And from here, I'm going to do draft create. That's going to be my first command. Right there, it automatically detected Python with 97% accuracy, and it says I'm ready to sail. Let me switch back to VS Code. Look at what it just added. So not only do I have my app py, now I have a Docker file that's telling me to go ahead and build, but I also have this charts directory. Remember, I kept talking about charts. For one, we have the values file. This starts to look a little bit cleaner and less scary than the Kubernetes YAML file I showed you earlier. This is where I start filling in all the important information. Image, pull policies, services. If I want to change the service type to load balancer, I type that right there. Whatever my container port is or my internal port. On line 12, from 12, 13, 14, 15, you see that I'm defining resources and limits. I mentioned that earlier. Remember C groups on how you can talk about hardware and you can address and use your CPU and your memory? That's a best practice. You should always make sure that you're setting limits. I don't want this pod to consume more than this amount of CPU usage or memory. That way the pod, if there's some sort of leak or memory dump or something, if it starts failing, Kubernetes as a scheduler can cut it and say, nope, something's wrong, I need to restart this. I can set replicas if I want to. All of these files are also built on the best practices of Helm chart, and Draft made it simple. But let's show what it actually did. So I have the values file. Under templates, I have all these other files I talked about, right? Deployment. So here's my deployment. I can specify everything. This is that templatized. So when we zoom in even more, under spec and replicas, whereas before I had a number typed in, or even if there was an image, I had an image address typed in. Now I'm just saying use what's in values for image repository. Everything's defined out as a template in YAML. So it makes it simple. So now I can go back to my terminal, and now I can just do draft up. And draft up is going to build my Docker image locally. It's going to push it to my local registry, and it's already running. The best part is it's already running in a Kubernetes cluster. So from a dev and ops perspective, if I'm a developer and I know my ops team is going to need to set up ingresses and networking and all this stuff that blows my mind, then I can just check this entire directory that I was just working in with my code, and now stuff I know they're going to need, into source control, and we can all work and collaborate in the same repository. So now my infrastructure becomes as code right alongside my application itself. And to prove it, remember the commands I typed earlier, kubectl get services, kubectl get pods? So we're going to go ahead and do kubectl get pods. There's my pod running locally. Kubectl get services. And there's my service. I didn't attach an external IP. I haven't gone that far. But that's my application running. So, and here's the best part. I don't have to go to anything locally or deal with port forwarding because I didn't set that up. I told it to run on port 80. So what I'm going to do instead is I'm going to do one more command, draft connect. And draft connect is actually going to connect to that instance that's running, set it up through a tunnel. It says it's serving on localhost. And we'll go over here on my left-hand side. I'll paste this in, and there's my hello ignite. Now, I can cancel this. I can go back over here. We'll close out of my charts. Go back to my app.py. We'll go ahead and change this and make this more personal because everyone likes it when it's personal. Go ahead and do Microsoft Ignite 2018. I'll save it, go back over to my terminal. I'll do draft up one more time because that's going to rebuild the Docker image. It's going to re-update it, do the rolling updates, rolling deployments. It's already done. Now I do draft connect again. I'll grab that local host IP address, go back over here, hit curl, and paste this in. Hello, Microsoft Ignite. I can iterate. I can test all this locally. I can now check it in. I can do whatever I want with it. And every time I do that, on the left-hand side, I'm getting post tests. Like I have complete insight into what I'm even playing with. Now, we're going to go back over to PowerPoint. Now we're going to talk about Azure DevOps that I set up earlier. What is it? I'm assuming most of the people in the room are familiar with VSTS. What was VSTS is now Azure DevOps, but it's so much better. You have Azure boards, which are things like Kanban boards, backlogs, your dashboards. Azure pipelines, that's what we set up. It's your CI/CD, and it's free for open source projects. If you were in the general session with Scott Hanselman yesterday, I was doing parallel jobs. If all my code that's out in GitHub, if I want to run 10 parallel jobs, I get that for free because I'm using stuff that's open source. I get unlimited build hours. My Azure repos are unlimited and free private repos. So if you don't want to, you don't have to pay $8 a month to GitHub, though I still do. Azure test plans, so if you want to do manual and exploratory testing. Azure artifacts, I can do package management for my Maven, NPM, and NuGet repos, or NuGet packages. This is where I was saying you can get started for free with Azure DevOps for open source. You have unlimited public Git repos. You have work tracking items. I can link those items as part of my pipelines. You heard me talk about gates if you were in the general session. Gates are things that you can use as part of the pipeline. And actually, I'll pause and I'll go back to that pipeline so you can see. If I were to go back and we'll edit this particular pipeline, say edit release, I'll have to click edit one more time. In theory, we'll go back over here. I can define quite a bit in my pipeline. So as a either pre or post deployment condition, I can go under gates. And under gates, I can choose the delay. How much time do I want to evaluate? And then I can add things in. I can do an Azure, we'll zoom in here a little. Click this again. I can do an Azure function, a REST API. I can do an is this even a valid extension? Am I allowed to? I can query monitor alerts. Outside of Azure DevOps, on my actual Azure account, I can set up what's called Azure policy. I don't want people in the subscription to be able to deploy out virtual machines that are in the Korea region. And then if I try to deploy out and violate corporate policy, remember we talked about IT and I need to stay in compliance and security, you actually get a failure with a readable error, which is always nice. So I'm going to leave. I'll show you another project here real quick. You'll actually get a failure that will tell you you're not allowed to deploy. You just tried to do something that is not allowed. So here's what this looks like. Zooming in. So if I define something in Azure, template deployment failed because of a policy violation. My deployment is not allowed. So there's so much power you can do with Azure DevOps, with policies, with gates, with enforcement. You can really kind of granulate things down as much as you need. Switch back to the PowerPoint. Private projects. If you do have private projects, it's still free up to 5 users. You still have unlimited private Git repos. You have still work tracking item and Kanban boards. And this time you get one parallel job, and you get 1,800 build minutes per month before you have to start paying for it. And CI/CD is the continuous integration, continuous deployment, that's also known as build and release. DevOps at Microsoft. For those who don't know, Azure DevOps is the same exact platform. I don't want to call it a tool. It's a platform. It's also fully extensible. You can build on top of it. Not only are the extensions available on GitHub and open source, everything you saw on the left-hand side where it said boards and pipelines and all of that stuff, that's all services you can turn on and off, and you can add your own. You could add your own widget. You can define your own dashboard. It's fully extensible. And Microsoft Teams, this is what they use. There are 372,000 pull requests per month. We go through 4.5 million builds per month. 5 million work items are viewed per day. We go through 78,000 deployments per day using Azure DevOps. Like, the numbers are insane. Now I'm going to show you one more cool thing. So I talked about how to use Helm charts, and you have all this stuff. And rather than showing you how to get a Helm deployment manually, creating a pipeline and doing all this stuff, we actually have an even simpler way to get that in Azure DevOps, rather than me showing you how to do that again from scratch. There's something called the Azure DevOps project. And it's available right from Azure, so we'll zoom in here just a little bit. Once I'm logged into my Azure account, I go to create a resource, and I'm going to scroll down. I don't even have to type anything. I can find DevOps project. It's one of the popular items. And every time I see that, I'm like, DevOps is popular. My favorite. I really wanted to say CrossFit Ops, though, but I'm pretty sure that'd be a branding issue. Anyway, when you start with the DevOps project, there's a variety of different languages we support right out of the box. .NET, of course, but we also support Java, static websites with HTML, CSS, Node, PHP, Python, Ruby, and then most recently, we also added support for Go. So I'm going to go ahead and pick, how about this? We'll get some audience participation. What language should I pick? Okay. I mean, I was expecting some open source language. All right, so we'll do .NET. We'll do .NET Core just that way it can play fairly across all systems. I'm not going to add a database, but I'll click Next. Now I can choose to deploy that particular application to any kind of framework. But the very first option is Kubernetes Service. So remember I showed you that slide of how to create a service and how to get started, and you type in all these commands, and then you have to deal with your Helm charts and yada, yada, yada. But I don't have a Kubernetes service. This will create it for you. So I hit Next. That's done. And now here's another one. I don't have an Azure DevOps account. You don't have to. We'll make you one. Or you can use an existing one. I've created so many at this point, I'm not going to create a brand new one. So we'll just go in and do one that I have. And we'll call this Ignite 2018 is awesome. That's going to be my project name. Scroll down a little bit. We'll leave it in the East US region. And then I'll hit done. That's going to go out, and that's going to literally build out every single thing I showed you in this demo. It's going to set up an Azure DevOps pipeline, end-to-end. It's going to set up my Kubernetes instance. If I didn't create an Azure DevOps account, it would create one for me. It's going to set up my project. It's going to add in my tasks. It's even going to give me a sample code and a website URL where I can go view my application itself. Now, that will take probably 5 to 10 minutes. And it's not really fun to just sit there and watch it deploy because it just says it's creating, it's doing all this stuff. So I have one that's pre-baked, just like Julia Childs. And I'm going to zoom out just a little bit so you can kind of see. One of the things we also talked about was application metrics and application insights. This even sets up application insights for your Kubernetes service. These on the left-hand side, it sets it up with my CI/CD pipeline. I have my repository beneath it, my application resources, Kubernetes service. If I click on any of these links, it opens a new tab with a deep link back over into where my code lives, which in this particular case, my code lives over in GitHub. This was my CI/CD pipeline that I looked at. If I want to go look at my build, I can click a deep link over into here. Here's my deep link back over into my build pipeline. Let me actually show you what we can also search for DevOps projects in here. And as soon as it drops down as a service, I'm going to bring up actually a separate project that has an even cooler pipeline. I overwrote the other one when we just did our deployment. So we'll refresh here. Yep, my mouse just stopped. We'll refresh. And funny enough, as if this actually did break, we have a second computer ready to go, pre-baked. So what I'm going to show you is a DevOps project that when you go into and launch it, you'll see the Helm tasks added in. You'll see Kubernetes tasks added in. You'll see your accounts and your subscriptions and everything else pre-done. Look at that. The page is unresponsive. I'm going to go ahead and cut it, and we'll switch over to my second computer here. Apologies. Gotta love technology. There we go. Go back over to here. Perfect. So I can see all my DevOps projects that I've ever deployed, and we'll go choose this one that's pre-baked. And I want to show you the deep links of the pipeline that was actually defined for you, because you watch me manually set it up. You watch me manually have to go through everything, and oh, that's funny. You watch me have to manually go through everything. You watch me have to manually test everything. And that was a little time-consuming. Ain't nobody got time for that. So instead, we're going to open this up, and you're going to see a real-time deployment. And all of this was code, everything that it gave me, everything that it did. I didn't have to do any of the tasks. I can go in and edit it. And we'll see what the tasks look like. And so when you get started with your Azure DevOps project, it creates everything for you to the point to where you literally can take your code, your .NET application, drop it in your code repository, and hit redeploy. You might have to make a few modifications on Helm in case your application points to a different port or you want a different ingress. By the way, if you want to learn more about ingress controllers and HTTP routing and how to set up really creative scenarios, I have an entire blog post available that'll be available in my slides for download. But look at these tasks that it set up for me. It set up not only build and push an image, it set up install Helm. It set up Helm init, Helm package. All these commands that if you're new, you don't even know those commands, and it sets it up for you. I can publish my artifacts. If I want to go over, and I'll switch back to here, we'll go over and take a look at my release. It's going to be the same thing. With release, there's only going to be 3 tasks. Because for Helm, rather than having to use kubectl, now I can use Helm commands. I can do Helm ls to list my deployments. I can do Helm rollback and roll back to a previous version. And simultaneously, it'll roll back my services, my deployment, my ingret, every single YAML file, it rolls back to whatever version was timestamped. So I'll show you this pipeline for the deployment. It adds in all of this with your Kubernetes cluster, with your service principals, your connections. You don't have to define anything. So I click even for Helm upgrade, we can see it'll have my subscription already added up, my resource group, my namespace, my chart path. It, when I zoom in, also has used tarballs. So it packages everything up. And I believe we also just announced Helm repositories that we have in Azure as well. So we have some really powerful stuff. I'm going to switch back over to PowerPoint, which I now have to reload on here. While that's loading, I'll try to get PowerPoint to work back on here. We just have one more slide to kind of recap here, and then I'll take some questions, actually. I wanted to leave a good amount of time. I know there's a lot of information we go through, so I want to leave a good amount of time for everyone to get their questions in. So I want to recap on some best practices. We talked about containers, we talked about DevOps, but some of the points of best practices for DevOps is making sure, again, you're delivering that value, right? How can you make sure something's valuable? You have to make sure your stuff is secure. The number one rule for any type of container orchestration is build small containers. So there's a blog post I want to say, I think it's 2 blog posts ago, where I talk about how to build a Docker container with a private repo. So for example, an Azure repo. And for those who don't know, you could access a private repo either using a PAT, a personal access token, or through an SSH key. So in the blog post, I go through how you could use a standard Debian Ubuntu image to go through and build your image. You do the standard multi-stage builds and build from and copy and get everything down. And you're able to save your SSH keys and authenticate and git clone and do all this cool stuff. The final image size is 83 megabytes. You change that base image to, rather than using Debian, and I use Alpine, and I switch my packages just a little bit, I get that image down to 8 megabytes. So focus on building small containers. Application architecture. I mentioned using namespaces. Focus on that isolation. Use Helm charts. That is a best practice. It's a way that I can stay organized. It's a way I can make sure my infrastructure and my pipeline is kept as code, is kept as source control. It's kept right alongside my developer's code. Role-based access control. I didn't talk too much about this, but my cluster has role-based access control. So that's one of the things I'm going to put in the blog post I'm going to write today, is talking about secrets. Secrets with Kubernetes allow me to safely store my image repository with my credentials, my username, my password, kept in a secret that's locked to a namespace. But even more so, it's then tied to a service account that's allowed to use that because I have role-based access control and security enabled on my cluster. Implement frequent health checks. There's one more thing I want to show you in Azure where you can actually go and view the monitor and the health of your pods. We talked about set requests and limits. Set what a pod is allowed to request. If I request 512 megabytes of RAM and 1 gigahertz worth of processing power, and my cluster doesn't have that ability, it won't even try to deploy because it's going to fail. So the entire purpose of a schedule in Kubernetes is to make sure that this can succeed. Be mindful of your services. Map external services accordingly. Don't always rely on load balancers. In today's demo, I set up a service and I pulled a load balancer. But can you imagine if you're running 25, 50, 100, 1,000 applications on your Kubernetes cluster? Do you really want to have 1,000 load balancers? Probably not. So that's where your ingress and HTTP routing and all of that comes in. Don't rely on that. Number one, it'll save you a ton of cost, but it'll also save you a ton of management. So I'll show you that monitoring, if you're not aware of, with your Kubernetes cluster. We're going to go back and take a look at Azure. We'll go take a look at my resource group. And this is my actual cluster. This is a cluster I use for all of my demos. So we'll scroll down and find my subscription. And it's my JDK8's cluster. I can go into it and I can look and see the health and see monitoring, see metrics, see everything right from my dashboard. So I can see all my nodes, of course. I can do insights. I can see any active alerts, any health issues, anything that you can set up. It tells you how many alerts you have. You can enable all of this. You can opt in. You can opt out. And you can do that manually just by enabling it. It's a simple add-on. Even if you already have your Kubernetes cluster set up, you can do that with command line. So we'll switch back over to PowerPoint. There's one more just cutesy slide, which is this one, that I just want to end on. So whether you're using Kubernetes, whether you're using release automation tools like Helm or Draft or anything, Microsoft's goal is to be able to accomplish what you do best, whether it's open source tool, whether it's Microsoft tools, whether it's whatever. That's one of the reasons why I wanted to make sure I mentioned about Azure DevOps, how it's extensible, how it's open source, certain parts of it, how you can add on to it. There's also in the marketplace, if there's an extension that doesn't exist, you can add right to that and publish your own extension. There's really a lot of great control. So for now, I have about 15 minutes, and I want to open up for any kind of questions. If there's anything I didn't cover that you wanted me to. How does Kubernetes compare to Service Fabric? Service Fabric is a little bit different in the sense that Kubernetes is more of, like I said, it's an open source orchestrator. It can run on multiple clouds, multiple platforms. I can run it locally. I haven't dove too deep into Service Fabric itself, but I know there's still a lot of limitations where it comes into comparison, and they're still working on a few things. One of the biggest benefits I find with Kubernetes is the fact that the community is so huge, and it's growing at such a rapid rate. And more importantly, again, my background was coming from the open source community. I'm not locked into one particular cloud. I can have multi-cloud scenarios. I can expand. I can grow out. I'm not locked into one particular framework or technology. That's that's a personal thing for my decision. Any other question? So you can, that was a new announcement that they just announced this particular session, so I didn't have time to honestly add that into mine. The question was, in other sessions, they talked about how to connect AKS to like web app and ACI and extend that out and manage it under the same umbrella. I believe that's an add-on feature that you can choose to enable on your cluster, and then it's essentially virtual nodes. So it's going one of the common questions that I get asked is, we know about Kubernetes and container orchestration. How do I take that one level beyond? Like, what's the future of where that's going to end up going? At some point, the fact that it's Kubernetes or container orchestration is going to go away, and we're just going to be looking at the abstraction of the container layer. And that was kind of the direction that we're going in with now virtual nodes. I'm no longer focused about the underlying infrastructure and the management of all that. I now have my just applications running, and I don't necessarily care. I just need them to run. And that really allowing AKS to tie over into virtual nodes and ACI sets us up for that direction. When you think about it from comparing both virtualization and containerization, how many people think about like the virtualization layer anymore? Like we're just thinking, I have a virtual machine. All right, I'm going to RDP into it. I'll SSH. Like we don't think about the technology that really underlines it. And that's going to be the direction of containers and Kubernetes, I feel. So I know that that was the intention of going with virtual nodes, is we're going more in the direction of you need to run an application, you can run it, you still have some management with AKS. I do plan to have, if you follow me online, which I recommend, most of my time is spent writing demos around this technology. So now with the new announcement, I will have more content available for AKS with ACI. Yes, I'm going to start hopping down. I'm getting blinded by the lights. This is my CrossFit now for the day. All right. Can start doing burpees. The question is, what's the best approach to move from ACS to AKS? First question I would have, do you have all of your code and your YAML files and your infrastructure essentially, do you have it in source control? Okay, so the best thing would be to start to spin up an AKS cluster. Make sure everything obviously is up to date as far as your YAML files, and then start to redeploy. Redeploy with best practices. Make sure you're using RBAC. Make sure you're using namespaces. There's no like migration path, so to speak, but Kubernetes was designed to make it immutable, right? I can immediately take this and deploy it right over there with one command. There's another thing I didn't show with Helm, but there's so the other option would be also to create a Helm package out of your charts, or to create a chart for your deployments. But there's Helm repositories that are public online, stable repositories. Jenkins, Artifactory, even Azure Service Broker. There's so many different Helm charts. You can deploy out any of those. If I want to deploy out a Jenkins build server, I can deploy it in under 5 minutes with one command because it has all the charts. And I can set up my values and my YAML and all my stuff appropriately. So for moving from ACS to AKS, if I start setting myself up for something that's scalable, like adding Helm charts and RBAC and namespaces and security principles and all these things, I now am not only updating my AKS, I'm updating my workflow. So it's streamlining me and making it easier for me to start moving more into the future. I can also set up a Helm repository and put those charts in a repository the same way I would my image for my business. That would be my recommendation. Other questions? Yes, perfect. Thank you. Okay. Yes. Great question. Great question. So the question is that he uses TFS, or which is our on-prem solution for Azure DevOps, VSTS formerly. TFS will become, and the question is then, when does he get those features and how can he update to it? So TFS will become Azure DevOps Server. As far as I know, I haven't heard any changes as far as the update cycle. So it's still going to be, it's usually 3 or 4 times a year. You have update 1, update 2, update 3. So that's going to stay the same. Right now, from what I've heard, I believe, I have to double check, but I believe the Kubernetes extension is available for on-prem. Helm is still a little bit behind, but that should be in one of the packages either coming late this year or early 2019. So, I mean, all the tasks and tools that I showed you now are available on Azure DevOps today, and they're free for you to get started, as we talked about. But on-prem there is going to be a lag. That's just always how it's been. My personal goal has been to work on streamlining the open source tools that we have in Azure DevOps. So also, if you are an open source developer, come help me make those tools and those add-ons better. Mm-hmm. So his question has to deal with Kubernetes and how it handles multiple load balancers and IP addresses and how he can update and kind of keep his applications with something that's reliable where he can always access it. That's where HTTP routing, which, by the way, is available as an add-on in AKS only. I don't know if it's in Google or Amazon yet. That was a new feature that was introduced back in May. But it essentially allows you to, it sets up, just like an Nginx like web server, it sets up an ingress controller and will route your traffic accordingly. So if you set up your Helm charts or your application to use an ingress, you can route your traffic and direct it in certain areas. So for example, on the cluster I showed you, I only have one load balancer attached to it, but I have multiple websites that can go to it, and I'm doing that using an ingress that I attach as part of my Helm charts. If you want to dive deeper into that and learn more about how ingress controllers and all of that works, that will be in my master tooling session where I go even deeper into Helm on Friday. And so I'll be sure to show, on Friday. And I do have a blog post about that too, where you can also set up, so my setup is unique. I have my website, jessicadean.com. That domain is owned through Google Domains. And then I set up actually a name server in Google Domains to point back over to Azure DNS. And in Azure DNS, I set up wildcard certificates. So I have star.k8s, and then the name server over in Google Domains is AZ. So that means my full address is star.k8s.az, jessicadean.com. Sounds like a mouthful, but I do it just for demos. And the reason why is with that wildcard, I can literally put anything I want in front of K8s. I can put Ignite, I can put Build, I can put Bob, I can put CrossFit, whatever. And as long as I attach that DNS to my ingress in my values file, and I enable ingress on my deployment and Helm chart, it'll go out and it'll grab that, it'll set up in my Nginx a way to route to star.k8saz Jessica Dean. Even more so, I set up what's called a cert manager on there that'll auto get SSL certificates from Let's Encrypt and automatically issue an SSL certificate for any new DNS name that I attach. So there's a lot more complicated stuff we can go into, which will be in the master tooling session because that's part of another demo. But that would be my recommendation for you, is rather than focusing on just load balancer IPs, focus on DNS. You're not going to go and give somebody like, yes, my website is at 23.101. So it's a little bit easier to manage, and then that way, again, everything's in your infrastructure as code. No. So if you have multiple so the question is, how do you monitor multiple clusters worldwide from like a larger scale? That's where, especially if your clusters are in Azure, I don't know, might be a silly question, but have you used Azure before on like the landing and the homepage? So on the homepage, you can set up a customizable dashboard. So what I would usually recommend is maybe have multiple dashboards, but you have one just for your Kubernetes instance where you can set up all your monitoring, your pods, I mean, like absolutely everything. One of the things that I've wanted for a long time in Azure DevOps is an ability also from my CI/CD tool to visualize my like pods, containers, services, all my clusters, everything. The same information I would get from a Kubernetes like API, being able to log in and see the dashboard, I want that from my CI/CD tool. Because you can tap into the API, you can write it. It doesn't exist yet. There are other tools, which I'm going to talk about on Friday. There's a tool called CodeFresh, and that actually gives you insight into all of your deployments, your Helm deployments, everything across multiple clusters. So I'll be demoing that as well. Well, if your clusters are in the same subscription, I mean, I guess, well, honestly, for mine, I have like 12 subscriptions on my account, but I can choose, when I drop down and say view all subscriptions, you can see all of my Kubernetes clusters. Yes. Yeah. Oh, several projects within one. Oh, absolutely. You might have to scale. That was that reliability and that scalability graphic. That's even Google's recommended way. That's in their documentation. So multiple times I've gotten asked is, do I set up a cluster for different environments? No, that's the entire purpose of what Kubernetes is. You have namespaces. Now, if there's certain regions like geo failover and like you want to have them in different regions and around the world, then there's use cases for that. But if you go to the actual Kubernetes documentation, even they tell you do not have multiple clusters. You're welcome. Yes. Yep. It's 1 or 3, yes. I haven't seen any more than 3. I don't even think Amazon offers more than 3. So AKS is a hosted control plane. So for all intents and purposes, it really doesn't matter how many there are in the control plane because we take care of it and we ensure the reliability. It's 99.7 SLA reliability, so it's not anything that you would have to worry about. I do believe if you want the technical details, right now it is actually 1, but they are working on giving you the option of 1 or 3. But with the way that, again, it works and the reliability and our SLA, it's the official answer from the team is it's not supposed to matter at the end of the day because you're no longer responsible for it and you're no longer paying for it. for failover, so when you have to distribute things, like you have your etcd, your schedulers, all the different like API aspects, rather than just having on one or two, where now it's like kind of split, you can spread it out a little bit easier over three. That's even when you start off on AKS, and the standard AKS group, create, deploy, whatever, is 3 agents. Yep. They're 1 right now. I know that they are looking at changing that, but again, at the end of the day, it's if that were to fail, if the control plane were to fail, it's going to immediately start back up because we guarantee the SLA of that. But I mean, ultimately, it comes down to like I guess our SLA agreement is the immediate official answer. But I do know, because I asked the team about it, as far as I have heard, is having 3 in your control plane is in the works. Any other questions? My session on Friday is 9 a.m. Yay! Patrick Lang is one of the senior engineers for so the question was hybrid support for Windows clusters in AKS. Is it coming? Is it there? What's the status with it? Patrick Lang works on the Windows Containers team. I believe he does have a session possibly today or tomorrow where he talks more about it. He can give you a better timeline. The short answer is Windows Containers is still new and they're still working on it. It is in active development. You can do Windows Containers right now with ACS Engine, but also, as we know, ACS Engine is kind of going away and AKS is going to be the thing. The team is working as fast as they can. But the downside, the one really big thing you have to tackle with Windows Containers is size, right? The number one thing I talked about was build small containers. It's really hard to do that when your base images are 1 gigabyte. So I know that the team is working on streamlining a bunch of things, even down to like a networking layer. I would honestly recommend checking out Patrick's session and then connecting with him, because he's one of the program leads and we'll have so much more information. There is also a Slack group, I believe, for that, and a weekly or like bi-weekly, possibly monthly, a regular sometime time frame call to actually get involved with the Windows ACS and AKS engine project. Let me run over there. Perfect. And then we do have just about 2 more minutes left, so if there's another speaker coming in, I want to be polite to them. Yes, so that was actually a new feature. I think that was enabled in 1.9 or 1.10 of Kubernetes, but you can do secrets with Key Vault as well now. And so that was another, when I talked about Azure DevOps pipelines and setting up like SSH keys and all that, you can even set up environment variables over into Key Vault as well. Like you can do a lot of integration with Key Vault now. You're welcome. I will take one more question. And then otherwise, I will be around the conference the rest of the week, so please come talk about anything Linux, open source, Kubernetes, CrossFit, puppies, everything. So the question was, I said, don't rely on load balancers. What would I use then? That's where I would use HTTP routing or ingress controllers. So that one ingress controller is going to have my load balancer, but I'm only going to have one. I'm not going to set up multiple load balancers for all of my projects. I might set up multiple ingress controllers if I need to route traffic, but in reality, as long as I have, so on my system, I have my Nginx ingress controller, and then I just register every deployment over to that ingress, and it'll give the right routing appropriately. So now I essentially am handling my networking as a part of my infrastructure as code and my Kubernetes deployment. And I have a big blog post about that and how to set that up, how to set up the records. And actually, right after I published that blog post was where they also had an announcement of HTTP as well. There's docs on how to set that up and enable it on your cluster. But that makes it a little more simpler and easier to manage. Thank you very much, everyone.